Today we're going to put everything together that we have learned so far in logic. And we're going to talk about arguments, and valid and invalid arguments. An argument is exactly what you think. It's sort of like think about a lawyer in a courtroom giving his final argument. It's made up of multiple statements. So for instance, here's an argument that I could tell you. If I like cats, then I like animals. A dog is an animal, therefore, I like dogs. The framework for an argument is the following. We have multiple statements, so like statement 1, statement 2, statement all the way up to however many statements we have. This is the building block to your argument. And then we lastly have a conclusion. If we go back to this last example, I said, if I like cats, then I like animals. That would be statement 1. A dog is an animal is statement 2. And the conclusion is given by that word, therefore. So the conclusion is, therefore, I like dogs. So the question that we want to ask now that we understand the framework of an argument is, can we turn this argument into a statement itself? And the answer to that is yes. All right, so here's our framework. We have sentence 1, sentence 2, however many sentences we have, and then the conclusion. The way in which we turn this into an actual statement in our framework is we combine all of the statements with and, so sentence 1 and sentence 2 and sentence all the way up to K. This is really just a run-on sentence if you think about it. If we go back to the last example, I could take, if I like cats, then I like animals, period. A dog is an animal, period. And I can make a run-on sentence by saying, if I like cats, then I like animals, and a dog is an animal. That's the same idea that we're doing here. We want to take all of the sentences and combine them with an and to make one big sentence, and we want all of these sentences to imply the conclusion. So what we have here is now an if-then statement. Here's an example. We could say, some philosophers are absent-minded. That would be one sentence. Nicole Malin is a philosopher. Therefore, Nicole Malin is absent-minded. That's how you would read the above problem. But if we wanted to turn this into one big mathematical statement, we would read this as, some philosophers are absent-minded, and Nicole Malin is a philosopher. Therefore, Nicole Malin is an absent-minded. One more way to phrase this is, some philosophers are absent-minded, and Nicole Malin is a philosopher, implies Nicole Malin is absent-minded. That last one is actually one big sentence, or one big statement. Here's another example. If Hurricane Gustav hit the grove of trees, then the trees are devastated, period. That would be one statement. People plant trees when disasters strike, and the trees are not devastated. That's another statement. Therefore, the therefore signifies to us that we have our conclusion. Therefore, if people plant trees when disasters strike, then Hurricane Gustav did not hit the grove of trees. All right. Now, we're not going to try to make sense out of if this is true or valid or what exactly is being said. What we want to focus on is simply identifying statements, and then we'll worry about whether this is true or false as an overall argument. All right. So what you can see here is that we have, if Hurricane Gustav hit a grove of trees, then the trees are devastated. That is a statement. I have multiple phrases, which I'm going to label as Hurricane Gustav hit the grove of trees will be P. The trees are devastated will be the statement Q. Now the reason why we really want to bring this up is that we want to see all of these put together. So People plant trees when disasters strike. We're going to call that R. And the trees are not devastated. We've already seen trees are devastated, so when we write the trees are not devastated, that corresponds to not Q with our labeling. We have therefore, and we see if people plant trees when disasters strike, that looks a lot like R. Then Hurricane Gustav did not hit the grove of trees. Well, Hurricane Gustav did not hit the grove of trees is exactly not P. So what you see here is that this whole argument is really comprised of 3 different statements, as well as their negations. One statement is Hurricane Gustav hit the grove of trees. Another statement is the trees are devastated. And the next statement is people plant trees when disasters strike. So now we want to turn this all into one big statement. Well, the red sentence is P implies Q. And, so remember that now that that's our one sentence, we combine each sentence with an and. So my next sentence, which was people plant trees when disasters strike and the trees are not devastated, that corresponds to R and not Q. I'm also using parentheses to separate the sentences here. So these 2 phrases right here comprise my whole argument. I see the word therefore, which tells me that I need that whole phrase to imply the conclusion, and the conclusion is given by if R, then not P. Alright, so we've just turned this argument into one gigantic statement. What we want to do now, in evaluating whether the arguments are true or false, is to build the truth table. At this stage, we've done all the new work. What we need to do now is just build a regular truth table. These might be a little bit long, but we know how to do it by now. Alright, I have here the whole truth table. I encourage you to pause here and try this on your own, matching your work with my work. Remembering that we have 3 statements, so all we're going to have are 8 different rows. Okay. So what I've done here on this last stage is I'm looking at the argument, which is in this column, implying the conclusion, which has truth values in the last column. This truth table looks slightly different because I'm looking at putting the end result in the middle. So I have false implies false is true, false implies true is true, etc. So actually, the argument has the following truth value. True, 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 true. All the way down. We have true everywhere. Alright, let's summarize what we've done. We want to turn the argument into symbols, and we want to make this symbolic argument into one statement. And then we want to evaluate the statement with a truth table. If the statement representing the argument is always true, as we saw in this example, then the argument is called valid. Otherwise, the argument is called invalid. Alright, so that summarizes analyzing arguments. We want to take an argument, combine each of the statements with an and to make our hypothesis. And then we have our hypothesis implies our conclusion. That is one mathematical statement, which is comprised of many, but if you have a mathematical statement, you can then make the truth table. You look at the truth table, and if the end result has all truths, it's valid. If you think about what it means to have an invalid argument, instead of having all falses, all we need to have an invalid argument is one false. Alright, that concludes our chapter on logic.